Okay, the children are now in bed and I get to return to making artwork. So we've been in the process of constructing this ash tree system that's going to create pretty pictures of things that grow into trees. And we've been developing code that gets us most of the way there. Like we've got to the point where we've got something here that seems to generate trees. That we must be getting pretty close. So now, so in order to make some progress, I'm going to go straight back to the code and do another little bit of cleanup. Assuming I can remember how to do it. There we go. No, that one. R! Give me R! There's R! Okay. So here we are back in our ash tree function. This is our script. I'm so bad at that. In our ash tree script, this is our main script. So we've got this set up. It loads the packages we need. It sources the two scripts that have our helper functions and our worker functions in them, and then it starts doing things. If we look at this, it seems to me that we're getting to the point that this chunk here itself is a fairly meaningful unit, right? This is probably the sort of thing that could be a whole tree, so that we could have a let's have something. Imagine instead of having all of this stuff here, we have something that looks like this. So that gets grow O W underscore Yay! I can type. So wouldn't it be nice if our code looked more like that? If we just got to, let's just Control X, I'll just cut that, make that go away. And then we can just delete all of that. And we can delete that. And this is now our whole script. So our whole script would just be load the packages we need, source our helper functions, set the seed for the random number generator. I guess I'll keep that on a separate line. And then it'll go through two processes. Oops, this will go grow tree and create a data structure, and then it'll draw the tree using that data structure, and then that'll output a plot, a ggplot object that would come out as a picture. Our whole code from beginning to end is basically 12 lines of code. That's starting to look good. All right, well, let's do that then. So inside our workers script, we will have a whole new function that we're going to chuck in here. So we'll call it grow tree, and that's also a function. So function, it doesn't take any arguments, and I'm just going to go all that code that I just cut out of our main script, I'll just chuck it back in here. So now our grow tree function is going to call grow. It'll create our sapling, and it will then start growing all the content of the tree, and then all we have to do is make sure that at the end it returns the tree. So return tree. Okay. So let's have a look at this now. Control S to save. Let's just click on a button and check. Good, it still works. It does everything that we need. If you need to be convinced again, I will just, in fact, I need to be convinced again. I like to restart my R session. I also have like a custom thing. I guess I haven't explained this at any point, but my R session, when I start, it goes, hey, we're ready to go, because it makes me happy. Okay, so now I've got a completely new R session. There's nothing in the environment. Now let's source it. We'll just make sure that everything works. It's working. Awesome. We can check that our seed is doing what we want it to. So if I just go over here and make this set seed 2, save it. So now we should see something that looks sort of the same but sort of different, because we'll be using a different set of random numbers this time around. So we'll source that, and we get apparently nothing. That's not a good sign. possibly something just froze on me. Let me source that again. Been having weird problems all day with my machine. Okay, there we go. I've been having these weird problems with my machine just freezing. It's been driving me nuts. Okay, so that's sort of similar but not the same. Let's change the seed again. Save it, source that. Okay, yep, we're clearly getting different output every single time. Cool. All right, so our function is coming along nicely. So our system is coming along nicely, our ash tree system. The thing where I now want to highlight in finishing all of this up is that, remember from last video, one of the things I mentioned is that we have two different types of iteration going on. So here inside grow tree, I've got a loop, this for loop over here. Here inside grow multi, I've also got a for loop. Now, this as a whole will work. This works fine. My system actually works. If I want to do something like, let's just run this for a few more generations. So let's run grow tree for 6 things now. I'll just highlight that. Just get to the point that you can see that we actually really do have something like the complete system. So save that, source it, and we get. Probably take. Is it frozen again, or is it? Oh no, I just sourced the worker script because I'm dumb. This is one headache you've got. Okay, we source the ash tree script, and that's starting to look like our final product. It's still drawing these tips as we go because I inserted the geom point thing. It's kind of unnecessary for the artistic look that we're going for. So let's just open the workers script again and go and find our individual functions. It's starting to get to the point that in a real system, I would be documenting and adding comments quite a lot. And I think when I get to the point of pushing this revised version back up to GitHub, I will add a bunch of comments so that you can see what it looks like when you actually document things. But for the sake of not taking too long, let's just keep going. So I will go, let's get rid of that geom point that's unnecessary. We save that. Go back up to the ash tree thing, and we'll go source, and takes a moment to draw this because it's a little slow, I guess. Doesn't seem to love me today. Come on, there we go. Now we're making progress. Okay, so this is looking pretty good. Okay, so what do we need to do to finish this up? Well, the thing I wanted to really do, if I go back to my slides, is start talking about iteration. I did say at the beginning that, or last thing, that we need to have a talk about what kinds of iteration exist. So, where I left things was pointing out that when we create a grow multi, we have a for loop in there, and that for loop is doing a particular type of iteration. What it's doing is it's creating 3 independent tips. So we take one tip or one set of tips as input, and we, for every tip that was in the input, it creates 3 new ones as the output. But each of those things is independent of each other, and we don't, once we've finished with this tip, we get to chuck it away. All we want to do is just output the new values. So let's take a look at the structure of this loop that we've written in a little bit more detail, and using a slightly simplified bit of language. Let's imagine, for the moment, I had just created a little list of squares. It's got 3 squares in it. This first square, second square, third square. And what I want to do is to turn all these into hearts. So I create an empty list called hearts, and then I write a for loop. And this is structurally speaking, this for loop is the same kind of thing that I wrote in the grow multi function. What I'm doing is I'm going to say for across 3 positions, I'm going to do some transformations. So let's do it bit by bit. We'll trace out how this loop is evolving and what's actually happening by just doing it step by step. What is happening in R when we run this for loop? Okay, so we get to the first line. I'm so sorry about the lime green. I had no idea how it was going to look when I first created the slides. But okay, R is currently on this line. We've created squares, which is a list. So what R knows about is this list of squares. It's now on the second line. It's created a list for hearts, but that's just a container object, and it doesn't contain anything right now. It gets to the start of the loop. It goes, okay, we'll create a new variable called position. And because we're going to iterate over a vector, position starts out having the first value in that vector, which is just going to be 1. So we've done that. So what I'm going to do here is I've got this little thing that says, okay, create this little placeholder variable called little s. And it will be grab the squares in the relevant position. So if we grab the square from position 1, boom, chuck that in S. We then apply our helper function, which we would imagine was called make heart. We had a bunch of helper function that we've written for the real system, and it helps and it turns this square into a heart shape. Yay! And then what we do is we pop that into the list. It then goes back, R then goes back up to the top of the list, moves position onto the next number in the sequence, so it goes from 1 to 2, and then we continue with the list. Sorry, with the loop. So S, again, we pop this square into that. We use our helper function to transform the big square into a big heart. We then chuck the heart up into the loop. We still haven't finished our for loop, so we go back up to the beginning. We change the position to match the third element of the vector, so that's 3. We then move the relevant square into S. We create a new heart. It goes back up into the list of hearts, and now at long last we are done. Yay! Let's just quickly. That felt kind of done. It kind of feels clunky, right? Like, this is a very mechanistic understanding of what the loop is doing, and that's kind of helpful in one sense. Like, you kind of go, okay, so I was going around and around and around, and that sort of makes a bunch of sense. But conceptually, that's not how I think of what's actually happening. When I'm growing my tree, I'm not thinking about grow this, grow that, grow then the other one. What I'm really doing is saying, take this one and go. Whoom. It would be nice to have some way of talking or thinking about our loop that lets us express it in that form. So this is where we start shifting from what I think of as programming with functions to functional programming. I mean, I'm not sure that there's that much of a difference, and I'm sure that proper good programmers will tell me that I'm wrong about this or that or the other. But what I really want to do here is start saying, well, instead of getting into the nitty-gritty, because our whole goal with functions is to talk in terms of abstractions, can't I just abstract away from all of the tedious little details of the loop and just tell me how I want to take one tip and turn it into 3 tips? What I want to do is create a map from an input structure to an output structure. So I want to go from my squares over here, which is our little list over here, and then what I want to do is create a new list that maps from squares onto hearts. So there's a function, and this is in the per package, which is part of Tidyverse, called map that lets us do exactly that. So it has 2 arguments, .x, which is the thing, the list of squares, the thing that we want to construct the map from, and then there's .f, which is kind of sort of a function, but it's going to be a little recipe for how to work with it. I'll expand on that slightly in a second. So the .x argument, which I don't usually bother to include in my code, but I'm trying to expand on this a lot in this video series. So that's the list of things we want to transform. This is our recipe for how we should transform an element of the .x input. So for every single .x, every single thing inside this squares list, what you want to do is turn it into a make hearts. And what we've got here, note the little tilde there. Formally, what that means is that I'm sending a formula to R, but the per package has a fancy little way of grabbing that formula, turning it into its own little anonymous function. It secretly turns this recipe into a function and then calls that function for every single element of the input list. But most of the time when you're actually just using it, it's easy enough just to think of, okay, so you just do the little tilde and then write a short recipe. And that's the way that I'm going to encourage you to think about this at first. So here's how we do it. So this is what's going on when I have a command like this with this map x equals squares dot f equals tilde make hearts of x. So there are our squares. Then I've got my recipe, which is make hearts. So I apply that recipe to each of the elements in the squares. And then the map function is the thing that kind of just pushes it across. I don't know which direction this is going to go when you're looking at it. And so it just goes, take all of those, evaluate all of them, and then return me the output. I find this kind of conceptually a much simpler way of thinking about what I am doing. Like, I'm not interested in the low-level details about how R kind of loops over stuff. I just want to say, take me this bunch of squares, turn them into a bunch of hearts. That's all I want to do. I want to create a mapping from squares to hearts, and that's what my map function does for me. That sounds pretty damn awesome. But it doesn't quite solve our problem. Go back to grow multi for a second. Grow multi doesn't take 3 squares or 3 tips and transform them. It just does one. So it takes one thing and applies it 3 times. It turns out that the solution to that is going to be really simple. Don't include .x in our recipe. So what we had before, right, when I was giving you my little squares to hearts mapping discussion, where we went like this. We say, well, for each element of this squares input, do the mapping. What if we do this instead? What I'm going to do is say, okay, just for every single element of this little x equals 1 to 3 list, or vector, just do a make hearts to this one fixed thing, right? And what I want you to realize when looking at this is kind of the for loop again, right? So we are doing the I wish I could work out where to point, right? But we're doing for, like we're going over or iterating over every single element in this x. So this is kind of like when we were saying for position equals 1 to 3. That's exactly the same thing. And then the thing that we do for each of those elements, or each of those things, is just going to be, okay, take this one square and turn it into a heart. And it's going to be the same thing every single time because this input here doesn't depend on the thing there, on the .x there. And so that's just going to take one square and turn it into 3 hearts. That's essentially the thing that we want to be able to do. So let's do this. Let's go back to our ash tree thing and see if we can't turn our code for grow multi, which is currently, let's find it again, shall we? Which is currently in the form of a, where are we? Grow from, draw tree. I'm going to reorganize this in a moment. Which is currently in this kind of elaborated for loop structure. Can I just rewrite that as a map? Okay, let's have a go at this. So the thing I want to create is branches. All right, so that must be branches gets. Okay, so instead of doing my loop, what I want to do is create a map. Okay, so we have our .x and our .f. I'll name them here. In fact, what I'll do is I'll put the .x over here on one line and the .f on another line. Okay, so what are we going to be iterating over? Well, our .x is just going to be this. So it's the same thing as that. So let's go back up here. We are going to iterate over 1 to 3. And then what we need is a recipe to apply for every single value in this input. And our recipe is kind of this, right? So what we're just doing is we're going, okay, we're really just growing from tips, like ignoring all of the ugly low-level stuff about we take the output of this, we put it into that, and then we put that into the branches list. That's not really like, that's the low-level detail we don't want to be bothering to think about. We just want to do this. So our recipe is just simply grow from tips. And we can just delete all of this. Go save. Let me just clear all my plots and check that this gives us the same result. So we go here, we go Control Shift S to source. Did we do that? I think we did. Take a moment. Is it going to draw? Is it drawing? I'm not sure. I'll just do it again just in case. There we go. Awesome. So what we've done is managed to take that list of like that loop that was going around and around and around, and just simply rewrite it as a mapping from thing we want to iterate over and a little recipe. So we want to apply this recipe every single time. Before I quit this one, there's one final little trick I want to mention to you. Map. So before, our little loop was growing branches as a list of tibbles, right? And then at the end of our process, what I said is I didn't actually want a list of tibbles. I just wanted one big long tibble. And so I've had to use the bind rows function to do that for us, which is fine, but again, it feels annoying. Like, I mean, I could just pipe this result to bind rows. But one really nice thing about the per package is that you can tell it what type of output you want. So if I want it to be just a list, map works fine. But if I want to turn it into a data frame, which will in this case be a tibble, do I want this data frame to grow horizontally? In which case I would go like bind columns, so df columns. No, that's not what I want. I want bind rows, so I want dfr. So data frame by rows tells us that what we're going to do is take the output and chuck it into one big long data frame or tibble and concatenate them row-wise. In other words, I don't need this line anymore. And thus, my entire function now reduces to this. So grow multi, we've taken the loop and we've just found a much more concise, kind of, I think I prefer it like that, way of writing the same thing. And that is very, like, I find this both powerful. Like sometimes it's faster when you write your code like that, but not always. Like, that's not the primary advantage to it. The main reason I like it is it's just a succinct way of saying what you're trying to do. I'm not actually trying to go around and around in circles. I just want to take this thing and turn it into that thing. That's what my map is for, and that's why I like functional programming. Okay, so we'll stop there. Well, actually, what I'll do before I do that is just to check to convince you that this is working. Let's go back over here to ash tree, source it, and come on. I'm hoping this is doing it. There we go. Okay, so you can see that it is actually doing what I hoped it would. Okay, so we've talked about how to, in this video, we've talked about how to get rid of one of our for loops, or to turn one of our for loops into a mapping operation. In the next one, I'm going to go down over here and talk a little bit about what's going on with this loop, because it may not immediately seem clear to you, but this loop has a slightly different structure to it, and so that's what we'll talk about next.